Discussing about moving coil galvanometer. Well, as you all know that in a moving coil galvanometer, this is the most common galvanometer which is used, the moving coil galvanometer. Here the coil is hung by suspension fiber. So as I will show you that what diagram it is. So you see, this is basically something like this. The coil is hung by suspension fiber. Say this is your mirror M, and let me show you the coil. And here is your magnets, and here too, where you give it to be your north pole, and here you give it to be your south pole. Now where a coil is hung by suspension fiber, as you can see, this is your suspension fiber. As current passes through it, it experiences a force due to the magnetic field of the permanent magnet. So these are your permanent magnets which you see. Now as the coil is inside it, it will experiences a force due to the magnetic field of the permanent magnet. Now the coil will rotate. There will be a motion of the coil. The coil will rotate until and unless the deflecting torque is balanced by the restoring torque of the suspension fiber. This will have a restoring torque, you know. Restoring torque. So the coil will rotate until unless the deflecting torque is balanced by the restoring torque of the suspension fiber. Now this for charge measurement, we will be using the charge measurement. For charge measurement, the galvanometer which is used is the moving coil galvanometer. Now here what happens, the charge passes through it for a very short amount of time, say delta t. It passes through it for a very short amount of time, and so as a result it will give an impulse to the coil. And the damping which is there, the damping is kept as low as possible. This will is kept as very low. The damping is kept as low as possible. So this is the entire diagram of a moving coil galvanometer, where you see that it is suspended by a suspension fiber, and the coil will rotate until unless the deflecting torque is balanced by the restoring torque of the suspension fiber. For charge measurement, we basically use the moving coil galvanometer, and the charge passes through a very short amount of time, which will give an impulse to it, and the damping is kept as low as possible. So this is your theory of a moving coil galvanometer. On the next tutorial or in the next video, we'll be discussing the theory of the moving coil galvanometer. Thank you.